Hey guys, today we're going to be talking about solving one-step equations. That's right, we're actually going to be solving for variables like x or y. Now, all of the equations we're going to be working with are linear equations. That means we are just going to have a single variable and it's going to be to the first power. So just x or y, maybe z, but you won't ever see multiple of them in combination with each other. And you also won't ever see anything like x squared or y squared or crazy stuff like that. Pretty straightforward, right? So let's see an example of a one-step equation. Something like x plus 3 equals 5. That's all there is to it. Pretty simple, right? So the idea behind one-step equations is we want to get the variable all by itself. I'm going to go ahead and write that down up here because you're probably going to hear me say it a lot when we're talking about solving for variables. You always want to get the variable by itself. Now the question is, how do you do that? Well, you'll notice there's currently something with the variable on that same side of the equal sign, right? What's over there with the variable? That plus 3. That plus 3 is what we want to figure out how to get rid of. Now, to get rid of anything that is with our variable, we have to do something called an inverse operation. I'm going to write that down up here for us too. An inverse operation. An inverse operation is something that undoes what it's currently doing. And I know that sounds a little weird, but let's look at our example and get some kind of hands-on idea of what I'm saying here. This 3 that's on the same side with the x, the 3 we want to get rid of, what's it doing right now? Yeah, it's adding, right? That 3 is adding. So we want to determine what is the inverse operation for adding or for addition that can get rid of that 3. I bet you probably already know what it is. It's subtraction, right? I'm going to write all of our inverse operations up here on the board. Addition has an inverse operation with subtraction, like we already said. They, quote unquote, undo each other, right? They're opposites. In that same vein, what do you think multiplication's inverse operation is? Exactly, it's division. So we always need to keep that in mind whenever we're trying to solve our one-step equations here. Let's go ahead and do it. I'm going to erase this. And then we're going to go ahead and use our inverse operation to get rid of this addition that's going on. What we need to do is we need to apply that inverse operation to both sides of the equation, meaning both sides of the equal sign. Since we have a plus 3 here, we want to undo that with subtraction, so we're going to take away 3, minus 3. And a common rule in math says what we do to one side, we have to do to the other to keep it fair and balanced. So I'm also going to do that here. Now, whenever I do that inverse operation, these numbers cancel out. They go away because we're adding something and we're taking away the same thing. Plus 3 minus 3, they're opposites, gone. Over here, that's not always going to be quite so simple though. 5 minus 3, right? We can look at that just like any other expression we've ever worked with. Well, 5 minus 3 is 2. So we have just x left on this side of the equal sign because we used our inverse operation to get rid of 3, and we just have 2 left on that side of the equation. And there we go. X equals 2, right? It's as simple as that. We can check our work if we wanted. If we go back to that original equation, x plus 3 equals 5, and we substitute 2 in for x, then we should get the exact same thing on both sides of the equal sign. Let's try it out. If x equals 2, I'm going to write 2 in place of that x. 2 plus 3, well, that's 5. And it makes sense to me to say 5 equals 5, right? We did it. We got the right answer. Let's do just a couple more examples here, because we want to make sure that we understand this idea of inverse operations pretty well. Let's try out y minus 7 equals 9. Now again, that golden rule is we want to get our variable all by itself. So we have a y right there. We want to get that all alone. Let's see how we do it. The only thing with the y right now is this minus 7. So I want to identify what operation is this doing? What is that 7 doing? Well, it's subtracting, right? It's being taken away from the y. So once I know what that other number or other term with my variable is doing, I can identify how to get rid of it. Since it's subtracting, my inverse operation is addition. So I'm going to go ahead and say plus 7 on both sides. Because again, what we do on one side, we have to do on the other. These are opposite operations or inverse operations, so they cancel out, they go away completely. Just think about it. Negative 7 plus 7, that's just 0, right? It's nothing. And that leaves y all on its own on that left-hand side of the equal sign. On the right-hand side, we have 9 plus 7, and we get 16. Y equals 16. We solved it. We got our answer. We're going to do 2 more examples before the end of this video. I know it's getting a little long, and you're probably thinking, oh, I already got this. I know what we're doing. We don't got to do more examples, but I just want to make sure. Let's say we have 5x equals 20. This one's a little different, right? We don't have addition or subtraction happening. What's that 5 doing to the x? Because don't forget, we want to get that x all on its own. So we need to look at what else is there. What do we need to get rid of, quote unquote, or what do we need to move to the other side? And in this case, it's that 5. That 5 needs to go. That 5 right now, it is multiplying the x, right? 5 times x is how we could read that. So I'm going to do the opposite of multiplication, division. I'm going to divide by 5. And I have to do that on both sides. Now I'm going to write it as a fraction because that's a way for us to write division. But you could also just use a divided by sign if you choose. Now that we have inverse operations here, multiplication and division, they cancel out, they go away, they're gone. Just the x is left. And on this side, we have 20 divided by 5. Well, we know 20 divided by 5, that's going to be 4. And we finish that problem. Our last one's going to look like this. X divided by 7 equals 6. Again, this is a little different, but we still just have that one number over there with our variable. And what's that 7 doing this time? That 7 is dividing. It's in the bottom of a fraction. A fraction bar, again, is just kind of like a fancy division symbol. So I want to do the inverse operation of division, which is multiplication. I'm going to go ahead and multiply both sides by 7. These inverse operations cancel each other out. They go away. We're just left with x. And over here, I get to go ahead and do what it tells me. 6 times 7, I get 42. I found my answer. If you have any questions about this, feel free to drop a comment below. I'll get back to you as soon as I can. Otherwise, guys, thanks for watching, and I'll see you next time.